Hey, check out this cool experiment. When green dye is added to this bottle, it turns yellow, and the dye only stays in the top half of the fluid. The dye can be changed to red by adding another fluid, and when the bottle is shaken, 3 layers appear with 3 different colors: blue, violet, and pink. After a while, the violet layer shrinks, and only blue is left on top and pink on the bottom. Let me show you how you can set up and carry out this experiment. I like to use a bottle of sparkling ice, which can hold up to 17 ounces of fluid. You'll also need some salt, 91% isopropyl alcohol, and universal indicator. After you empty the bottle of sparkling ice and remove the label, add 240 milliliters or 1 cup of water to the bottle. After this, measure out 50 grams of salt, add it to the bottle, and shake until it dissolves. Once the salt has dissolved, add the 91% isopropyl alcohol. Fill it almost all the way, but leave a little space at the top. At this point, you'll probably notice that the salt water and the isopropyl alcohol don't mix. The interface between the two looks kind of beautiful. The next step is to shake the bottle to mix the 2 fluids. The first time this is done, you'll see a bunch of air bubbles form. At this point, you can easily see that the initial mixing of the salt water and alcohol results in 3 layers. A layer of alcohol on top, a layer of salt water on the bottom, and a mixture of the 2 fluids in the middle. Ultimately, salt water and alcohol do not dissolve in one another. We chemists say the 2 fluids are immiscible. Because of this, the mixture of the 2 fluids in the middle doesn't last indefinitely. We call such a transient mixture an emulsion. You'll notice that the emulsion layer gets smaller over time as it reseparates into an alcohol layer on top and a layer of salt water on the bottom. Once the emulsion finally disappears, it looks like there's just a single liquid in the bottle. However, adding dye to the bottle reveals there are actually 2 layers present. The dye usually only sinks into the alcohol layer. Being less dense than salt water, it floats on the layer of salty water. The dye I'm adding here is universal indicator, which is an acid-base indicator. The indicator changes color depending upon the pH of the fluid or how acidic or basic it is. The yellow color you see indicates a pH of 6, just slightly acidic. Notice that the addition of acid to the bottle causes a color shift to red, indicating a drop to pH of 3. Now I'm going to add base to the bottle instead of acid. In this case, I'm going to add enough base not only to neutralize the acid, but to make the overall system basic. It's interesting to note that I don't usually see a color change in the fluid as I add the base. But check out the magic that happens when I mix up the contents of the bottle. Look at that. Isn't that a beautiful purple color? And that purple color tells us that the system's at pH 10. Very basic. But whoa, check it out. There's a bit more going on here. It's the emulsion layer that's violet. The alcohol layer is blue, while the saltwater layer is pink. This interesting effect occurs because there are actually multiple dyes in universal indicator. One of these dyes is called phenolphthalein. Phenolphthalein happens to be colored pink in a base. As you can see here, the phenolphthalein dissolves in the salt water more readily than in the alcohol. The other dyes in universal indicator dissolve better in the alcohol layer. Now we can understand the colors observed in the 3 layers a little bit better. First, recognize that if phenolphthalein was not present in universal indicator, the universal indicator would appear blue at high pH. The addition of phenolphthalein to universal indicator imparts an additional pink color at high pH. Since blue and pink make violet, universal indicator appears purple at high pH as long as phenolphthalein is present. But remember, phenolphthalein dissolves better in salt water than in alcohol. So when the bottle is shaken, the phenolphthalein is extracted into the saltwater layer, making it appear pink. Because the phenolphthalein has been removed from the alcohol, this layer appears blue. The emulsion, however, contains both liquids. Therefore, it contains phenolphthalein plus all the other dyes in universal indicator. So it appears purple. Because universal indicator displays a variety of colors, you can tune the pH in the bottle to show a bunch of different color effects. You can also add acid or base to cause crazy color changes. Be sure to let me know in the comments if you think you know how I got these colors and color changes to occur. Hey, also let me know in the comments if you try this experiment on your own, and especially if you tried different variations, like using food dye instead of universal indicator. And thanks so much for watching.